Let's discuss today's lead code problem, shift shifting letters to. So the question states that we are given a string s that is of lowercase letters and a 2D integer array shift. Okay, if I copy one of the test case, the string is given to us and the shifts array is given to us. That is a 2D array having multiple 1D arrays with three elements. Okay, let's write them down. Okay, 0, 2, 1. This is the given input. So you are given the string of lowercase. All the elements should be lowercase in this. And we are given the 2D array shifts where the 1D array is consisting of three elements, start, end, and direction. So it will be start, it would be end, and it would be direction. So what does this mean? So for every I in the shift, the characters in S from index start to end inclusive. That means from index 0 to 1 for this test case, forward if direction equals to 1, or shifts the character backward if direction equals to 0. So we need to perform some computation from the start index till the end index in the S, and the direction is specified as 0 and 1. What does the direction means? So shifting a character forward means replacing it with the next letter in the alphabet. So if we are moving forward, then the A would be replaced by B, and if we are at Z, it would be wrapped. So after Z, we would be get A. And if we are moving backward, so moving backward from A will result us Z, and moving back from B will result us A. Okay, so this is specified in the question. Similarly, shifting from backward means replacing the previous letter in the alphabet. Okay, we got that point. कि अगर if we are at the last, let's suppose Z, and we are moving forward, then it will wrap around to form A. And if we are at A and we need to move backward, we would wrap around to Z. Uh, Return the final string after all search shift to S are applied. Okay, so these all operations are applied on the S, and we need to return the S after these certain operations. Okay, so it seems to be a simple problem. So let's kind of discuss the given test cases. So 0, 1, 0, 1, 2, these are all the shifts. So A, B, C, 0, 1, 2. So we need to perform a shift from that is starting from 0 ending at 1. So start, end, and we need to move backward. 0 is representing backward. So A would be replaced by Z, B would be replaced by E, and we don't need to perform for C. So shift 1, after shift 1, this would be the case. After shift 2, uh, the shift 2 have the starting index from 1, the ending index from 2, and we need to move forward. So we have A, then we have C because we would be moving forward. But here's the case, the shift would be apply on this. The second shift would be apply on the resultant shift of 1. So I would have done a mistake by performing the shift on the given string. So this string would be transformed to ABC, would be transformed to ZAC after first transformation. The second shift is 1 to 1, that will start from this one and end at this one. We need to move forward. Okay, then this would be A would be turned to B and C would be turned to D. Then Z, B, D would be the resultant string after second shift. The third shift is shift 3. We have 0 to 1. So from starting from the 0th index till the 12th index, we need to move forward. So Z would give us A, B would give us C, D would give us E. Okay. Now no more shift are left, so this would be our resultant. ACE, is that the same as specified in the output? Yeah, it is. Okay, ACE is our output. Now we try to do for the test case 2, we try to implement the given algorithm. Said as shifts, the first shift is would be done on this DZTS0123, shift is from 0 to 0 and move in the backward direction. So for this, starting would be this and ending would also be this. The direction would be backwards. So it would be CZTS after shift 1. Okay. And we need to perform shift 2 on this 0, 1, 2, 3. The shift 2 will be 1, 1, 1. After shift 2, we have 1. We need to perform from 1 till 1. Direction is forward. So Z would be turned to A. CATZ. After the specified shifts, the resultant string would be CATZ. Okay. Yeah, it's the same. So the approach that I can think of, that is the brute force approach, as it is specified in the question. What I'll do for the given shifts, what I'll do, I first copy this particular test case. So I don't need to write it. Okay, I have this particular test case. What can I do? I will traverse this shift. Okay, traverse this shift. For every particular shift, I will change the character specified as per the moving direction. If it is moving backward, I would change this A to Z. Okay, so the simple steps that are provided in the given question, we'll do the same and try to find the answer. Okay, so I have previously implemented it. I just copy paste it. Give me a second. So so the simple algorithm that is specified in the question, what we can do, we'll start, because the execution of a program will start at shifting letters. I would make a string builder because strings are immutable in Java. So I would take a string builder, and for the shifts in the shift array, I would traverse the particular segment of the string, perform the shift that is basically based upon the direction. If the direction is 1, that we need to move forward, then we get the integer value of that ASCII value of that particular character, and it is specified कि we only have the lowercase. So that's why we are subtracting it with small lowercase a plus 1, because we need to move forward, and because in the case we don't want to move outside the range of 26 characters. So that's why I have a modulo operator specified here plus the character that because I need a character value now. So that's why I'm adding plus a, so that in case I would be having 25 plus a, that is character. First it would be converted into character, that is 25 mod 26 would be 25, and plus a would give me z, and that would be a character. Okay, I would return from here, and similarly if I am moving in the backward direction, I would be getting the character at index, the particular index, find its backward value, wrapping it up using the modulo operator, and returning the particular character. So for each and every shifts we need to do it. So if in this particular algorithm, if we analyze the time complexity, let's assume the size of shift to be m. Okay, m. So order of m time to traverse all the elements in the shift. Okay, to cover all the elements in the shift, we require order of m time. If uh, we need a inner loop that will start at the starting index and ends at the ending index. In case it would be starting from 0 and ending at n, that is basically the size of string. In that particular test case, it would be requiring, in the worst case, it would be requiring order of m into n. And that is not a good time complexity because it would give us the TLE error as specified in the question. Yeah, yeah, it is giving us TLE. So we can't, what we can say, move forward with this particular approach. But this gives us the solid understanding that what abstractly we need to perform. Okay, we have a time complexity, and what is the space complexity? We are just maintaining a string variable that will not be the part of our, what we can say, computation process. So it is just to return the answer. So we not consider it as the part of our computation. So it would be constant. Okay. Now, if we can't do it in this way, how can we perform this particular operation? Let's see. So if I analyze it, one thing I'm sure of is I need to traverse this shift. Okay. And if I don't perform any pre-computation, then I need to traverse from the starting to the ending. It is for sure कि if I don't do a pre-computation for each of these elements, I need to perform a traversal from the starting till the ending index. So I need to perform some pre-computation. Whenever I think of pre-computation, I my mind remind me of prefix maintaining a prefix array. But for what I need to maintain a prefix array? So we just need to maintain a prefix array for the string. The string is having A, B, C. I would maintain a prefix array for this 0, 1, 2. Okay, 0, 1. So if there is a shift between a starting index and an ending index, what we'll do, let's suppose we need to move forward. So we need to move forward from 0 to 1. In this case, we need to move forward by 1. So I would add here by 1 at the starting only, at the 0th only, and I can cumulatively find the number of shifts for the next occurring characters. So for the 0th, that is basically 0th index, I would increment it by 1 because I need to move. Okay, so in this case we need to move backward. We would be subtracting it by -1. Okay, now it would be from 0 to 1. So we don't want the second index to be subtracting 1 from its current value. So here we need a 1 to balance it out. For this particular vector, I don't want to move backward. Okay, ठीक है. I just got a gist of it कि हाँ ठीक है ऐसा हो सकता है. Then we move to the next 1 to 1. So this is basically a rough idea what I'm thinking. 1 to 1. So 0, 1, 2. So I am at 1. I'm at 1. I need to perform the forward operation till 2. So if I'm at 1, I would increment that the value that is present at that particular index, the starting index 1, and because I need to perform till from 1 to 2, so I need a third index also, so that I would counter it out कि this operation would be performed till 2, तो nullify it out for index 3. ठीक है. Now if I am at 0 to 1, I'm at 0, I need to move forward. Okay, the current value is negative because there would be a operation in the backward direction. Okay, I need to move to the forward, so -1 plus 1 will nullify it out, it would be 0. So all the operations from 0 to 2 would be getting a 0. Okay, and we would be having till 2, so forward action would be provided till 2. Okay, after 2 I would to nullify it out because I was moving forward. I would add, I am having -1 here, so I need to move forward. I would subtract the value out as -1. This would give me -2. Okay, so we in this particular, what we can say, by performing these operations we are specifying key for a particular character what are the resultant number of shifts after performing all the shifts. Okay, we are just calculating the resultant number of shifts by basically having the net number of shifts. So what we will be doing, this is our prefix array 0 0 1 1 minus 2 0 1 2 3. Okay, this will be our prefix array. Let's see how would we form our string from this. So for the zeroth index, the resultant shift would be 0, so it would be remaining a as it is. ठीक है, I would maintain a net shift variable. Initially it would be 0. I move to the next, it would be 1. Okay, so for B I need to do a net shift of 1. We'll make it as C. Okay, no problem. I move to the next. Net shift till previous was 1. It would be 1 plus 1 will give us 2. Net shift for C is 2. DE. It would become E. Okay. I move to the next. I don't have any next character. Okay. ECE will be my shifted string. Yeah. So what I have done, first I'll perform this operation on the second test case 2. B, Z, T, Z. The shift are 0, 0, 0. Then we have 1, 1, 1. Okay. Let's see. I'll first traverse this. I am sure that the prefix array would be of size 0, 1, 2, 3. That is 5 size. Because I need one extra block of array to maintain key for from this index to this index, this forward or backward operation to be applied, and we need to nullify it. Okay, so yeah, so for the first shift all of them would be 0. First shift will be in the backward direction, so it would be a -1, and it would start at 0. Current value is 0. Okay, start at -1 and ends at -1. So for 1 we need to nullify this -1 by 1. Okay, so by adding one value, so for this it would be 1, so that the resultant would be 0. Okay, now I move to the next, it would be 1. So my forward operation would be starting at 1 and ending at 1. So the current value of 1 is 1. It would give me 2. Okay, and it would be from 1 to 1 index. So for the 2 I would be having a -1 value. Okay, so this would be the prefix array. the next shift starting from the index 0 would be -1. So for D, we need to do a -1 shift. That is, it would become C. For the index 2, the next shift would be 1. So for Z, we need to move forward. It would become A. The net shift for this is 0. T would remain 0. T would remain T. We need to move to the next, that is Z. It would remain Z as well. So CATZ would be our resultant. Yeah. Let's do one more test case to understand it more further. In this, I would specify the condition key for the starting shift, for starting index of shift. I just need key prefix of start index would be plus equals to, I can do plus equals to the shift value, and the shift value would be 1 to move forward and 0 to move backward. Sorry, -1 to move backward, not 0. Okay. And the second thing, we need to specify the ending. So the prefix of, because from starting to ending inclusive it is specified. So from starting to ending, end index plus 1 would be specified with prefix of end index plus 1 minus, because I need to nullify that shift value. Okay, this would be done. And then we need to find the resultant sum. So let's have a random test case. Let's suppose we have a name, let's suppose Himanshu, and the number of shifts would be, so the number of indexes are 1 2 3 4 5 6 7, 0 to 2 with direction as 1, 1 to 5 with direction as 1, 2 to 2 to 4 with direction as 0, 5 to 6 with direction as 1, and one more we can take, 2 to 5 with direction as 0. Okay, let's see. I'll just zoom it out a little bit. Okay, in case you need these particular notes, you can check them out in the description. Okay, now I need to maintain a prefix of size 9, 0, 1, 2, 3, 4, 5, 6, 7, and 8. All of them would be 0. I need to perform the shift from 0 to 2. 0 to 2, the direction is 1, that is forward. It would be a forward direction, that means from 1 we need to add the shift value 1, and till 2 it is specified. So for 3 it would be the the current value, that is 0, minus the shift value is 1, that would be -1. Easy. Again, for the next shift we would be having, let's zoom in a little bit. Okay, 1 comma 5, 1, the direction is forward, forward is 1. So for the starting index, I need to add the current value plus the shift value. So at 1, I just need to put 1. Till 5, this particular shift would be done. So for 6th, we need to specify, because it is moving forward, we need to minus a -1. That would make it as -1. Sorry, shift value would be 1. So -1 plus the current value. That would give me -1. I move to the next. it would be 2 comma 4, starting at 2 ending at 4. The direction is backward. So starting at 2 ending at 4, starting at 2 moving at backward direction, it would be minus 1, because the shift value would be minus 1 and the current value at the starting index is 0, and it will work till 4. Okay, so at the fifth we need to specify the current value is 0 minus shift value is minus 1, it would be 1. Okay, now we move to the next 5 comma 6. 5 move in the forward direction, so plus 1, and till 6 it would be, for the 7 it would be minus 1. Okay, so here we would be having 2, here it would be having minus 1. So 2 comma 5, 2 moving in the backward direction, so we would be having minus 2 here till 5. So at the 6 we need to specify key till 5 we would be having minus 1 operation moving backward. So minus 1 minus shift value is minus 1. Okay, it would give me 0. Okay, so after the shift this would be my prefix array. Now the name is Himanshu. Himanshu. So the first index 0. The name is Himanshu. The net shift is 1. Okay, the net shift is 1. So for index, say A B C D E F G H H I, so it would be I. Okay, at index 0. So for index 1 the net shift would be 1 plus the 1, so net shift would be 2. So for I it would be ij, A B C D E F G H I J and K, so it would be K. Okay, now for index 2 the net shift would be 0. 2 minus 2 would give us 0, so it will remain as M. Index 3 and net shift would be minus 1, so A would give us Z. Good. Index would be 4. 0 1 2 3 4 5 6 7 4, that is N. The net shift would be minus 1, so M would be here, MNOP. Index would be 5. The net shift would be minus 1 plus 2. Net shift is 1. So index 5. ST. ABCD FGH IJK LMNO PQR ST. It is T. Okay. We'll move to the index 6. The net shift would be 6. I have moved to the 6. It is having 0. Net shift would be 1. H. ABCD EFG H I. For the index 7 it would be 0. The net shift would be 0, it would be U. So if we combine the particular character A K M Z M T I U, this would be my transformation from Himanshu to the particular word by performing this number of shifts. Okay, so I can easily code it out. The coding would be easy, so I would just show you the code so that it would save your time. So I have previously coded it out. Uh, yeah, the UI of lead code has been changed, so थोड़ी प्रॉब्लम तो आ रही है इसमें. एक बार इसको ना एडिटर पे लेके जाता हूँ ताकि अच्छे से समझा पाऊँ. ठीक है. So we need to maintain a prefix array that would be having a size of n plus 1. So for we need to do a pre-computation for each shift. Maintain the next shift array. For each shift, I would be getting its direction. If the direction is 1, the shift value is 1. If the direction is 0, the shift value is minus 1. Okay. Uh, so if the shift is starting at the starting index, I would add the shift value, and it would be until a current ending index. So I would just zoom in out. Okay. So it would be at till the ending index. So this would be inclusive. So I would add plus 1 key, subtract this particular shift value, whatever it may be. After that, I would maintain a net shift variable. I would, because we are coding it in Java, so I would be having a string builder. If the net shift for the particular index, we can find it out. So for the particular index in the string, I would find its integer value. I would add the net shift. Then I perform some modulo operation so that if after adding the net shift, it is giving us a greater value, then we have apply a modulo operator. In the case it would giving us a negative value, that's why I have added it plus. So in the case of to handle the backward operation, I would add plus, and again I have performed the mod 26 operator so that it would remain within the range of a to z in the lower case. And then I have added a so that I could put in the new string, I could append this shifted character. After that I have returned, after the loop I have returned the new string by converting into toString. Okay. So it would be running because I have moved it from the accepted section. I would paste this in the editor here and try to find its time complexity. So if the shifts 1D array count as m, if we analyze it, so order of m will be the time complexity to traverse this shifts array, and order of n time to traverse this string. So the total time complexity requiring would be order of m plus n. That is quite good. And the total overall, what we can say, the space complexity would be order of n. That is, we are maintaining a pre-computed array. So uh, this would be the time and the space complexity. So all the questions from January 1 to January 5 are basically based upon the prefix array or the pre-computation. So whenever we need to do some kind of pre-computation, we prefer to move with the prefix array. ठीक है? Yeah, and it will drastically improve our time complexity. So initially we are having the time complexity of m into n. Currently we are having our time complexity of m plus n. So this was the solution to the today's lead code problem. If you have any doubts, you can ask in the comments, and for more further videos, you can subscribe to the channel. Bye bye.